Hi, my name is Hao from Waseda University, Japan. Today I'm honored to present our work, Reinforcement Learning for Idea-Based Non-Autoregressive Neural Machine Translation. This work was done during my internship at exacerbating AI lab. Preparing appropriate training data for AI models is a non-trivial task, often exacerbating exposure bias. And reinforcement learning is known for its ability to tackle this exposure bias and optimal mismatch. However, explorations of IL for NAR are still scarce. In this work, we apply IL to NAR, demonstrating that IL with self-generated data can enhance the performance with idea-based NAR models. We focus on Levenshtein Transformer, which is a prominent idea-based NAR model in our experiments. And in this work, we mainly explore two different reinforcement learning methods. The first one is stepwise reward maximization. This method calculates reward for each edit version using score differences from one previous edit. For example, we have some edit operations here: delete, insert, and replace. We will calculate blue score and IL gradient after each edit operation and update the model. The advantage of this method is that it's easy to learn since each step's reward is calculated separately. However, it's more prone to learning bias since the edit process is inherently multi-step, but our training process is single-step. Another method is episodic reward maximization. This method edits each sample multiple times without a branch and calculates rewards only once, giving all actions the same weight. We still have the same edit operations here: delete, insert, and replace, but we will only calculate blue score and IL gradient after all edit operations have done. The advantage of this method is that it allows unbiased learning, but it may not be efficient since all actions share the same weight, which means that there is no information about which actions were good or bad. Okay, here is our result. We use Levenshtein Transformer as our baseline and apply the two different reinforcement learning methods to the Levenshtein Transformer separately. We can see that the episodic model showed notable improvement of the baseline, while the stepwise model showed only limited gains. Okay, so why does it happen? We show the stepwise reward model's standard deviation of the advantages in each edit operations here. The advantage is this part, the reward minus baseline, in the reinforcement learning equation, and a higher standard deviation of this part indicates larger fluctuations in positive gradients. You can see that the stepwise model shows notable higher standard deviation in the early stage of edit operations, which suggests that the model disproportionately focuses on early operations, potentially leading to uneven learning and worse results. Okay, for summary, we explore the application of reinforcement learning to idea-based non-autoregressive neural machine translation. By empirically comparing stepwise and episodic reward maximization, we analyze the pros and cons of these two different IL approaches. And by incorporating episodic IL into the training process, we can see that it provided a significant performance improvement, which indicating that IL can mitigate exposure bias or problem in NAR training. And we also have done more experiments in our paper. For example, we have done experiments which about the temperature settings in NAR software sampling. If you're interested, please read our paper. Thank you.